this last session actually features two people who really have played a special role in this. I will introduce Professor Brent Seales first, and then Professor Richard Yanko before his presentation. But really, so you've already heard throughout the day about various aspects of their works. So this is sort of formal introduction, and I hope is not too formal. But Dr. Brent Seales is the Gill Professor and Stanley and Karen Pickman Heritage Science Chair of Computer Science and the Director of Graduate Studies of Data Science at the University of Kentucky. He's been working for really 2 decades to use high-tech methods to restore lost texts. And people call him the man who reads the unreadable. All the projects that you've heard, all the efforts you've heard today are so exciting, but they really are sort of, in a sense, the culmination of people like Professor Seales and Professor Yanko through their decades of, I would say, vision, ambition, and scholarship, leadership, and also perseverance. So with that, Professor Seales.
Thank you, Jane. That's I don't know anyone who calls me the man who can read the unreadable. Actually, I can't read any of these languages. It's on my website. Oh boy! So the people who built my website have decided that I can read the unreadable. I'm not going to be bound by this title because I picked it a while ago. But I would like to talk to you today about EduceLab and its the way it is providing an avenue for me for aspects of the future of what you've been hearing about today, which is the present. Educe comes from, Educe is actually a real word that you could use in Wordle because it's 5 letters. And it means to bring out from data or to develop something that is latent but is not on its own explicit. I was shocked to find this word and its meaning to be so close to what I've actually been working on to describe in one 5-letter word what it is I think technology can do with some of these damaged materials. And so I named the lab EduceLab. And if you just Google that, you will find me. And you will find that the core effort that started the lab and gave us the impetus to be able to expand into the things I'll talk about today has come from the work on the Herculaneum scrolls. It's come from that. And so you've heard talks all afternoon about this topic and around the work we've done. But on my next slide, there's one thing that you haven't seen, and it does represent for all of us the true culmination of our work, of our academic work, and that is when comedians make fun of your work.
It's too delicate to unravel.
Well, how do you know? Have you tried to unravel it?
Yeah, good point.
Yeah.
Yo, just pick the least important looking one and open it.
Open the scroll.
Open the scroll.
Open the scroll.
Open the scroll. Open the scroll. Open the scroll. Open the scroll. Open the scroll.
Let's move on.
Open the scroll.
Thank you, The Daily Show, for introducing my talk today, because in fact that's exactly what we've done, but not in a way that would make Humphrey Davy blush or that would destroy another 40 or 50 scrolls in the back room with mercury or with a knife. No, we've used tomography, and the confluence of 4 or 5 important technologies without which none of this would work. I want to show you first experiment and give a little bit of history, and then I'm going to talk about EduceLab and the infrastructure that it provides and the motivation for us building that infrastructure. And then I'm going to finish with some shovel-ready projects that are exciting to me and go beyond Herculaneum. And by shovel-ready, I don't mean finding Plato's grave, okay? That's not the shovel that I'm talking about. Thank you for that laugh. That was a joke. Yes, it was funny, I thought. No, shovel-ready means that we have all these tools now from the work we've done with the contest and the breakthrough with Herculaneum, and we want to use those for other damaged materials to the degree that we can. And so I want to show you some examples of that. First, this virtual unwrapping experiment, this was round about the year 2000, and on the left, you see the images that we were able to derive from the virtual unwrapping of a single experimental piece of canvas that I built in the lab and then wrote on. And that virtual unwrapping gave me the confidence, maybe unjustly so, but it gave me the confidence to start to believe that there would be real material that, that virtual unwrapping would help us unlock. Not just an experiment that I made, but real material. And so I think it's amazing that, here we are at the University of Michigan, and I'm sitting with Professor Yanko, who helped get me invited to give this talk at Oxford in 2005. He sent some emails, and he said to Bob Fowler, I know you've started this Friends of Herculaneum thing. Maybe you should have Brent come and speak about his ideas for virtual unwrapping. And, Bob actually did that. He actually let me come to Oxford. And here I am talking about, in summary, virtual unwrapping in this photo in 2005 in July in Oxford. And what was happening at the same time was that Richard himself took me to the library in Naples as a way to try to spur the possibility of doing virtual unwrapping with Herculaneum material. Here I am in the director's office, sneaking a picture of Richard when he's got his back to me. But we also both posed in front of the very material about which we were speaking. And I took his picture and he took mine. And after that meeting, I got the result from the director of the library, Gian Caspero, who said that he was decidedly unimpressed with my presentation. He said it very nicely in very formal Italian. And so that sort of ended my ability to do anything at the time with Herculaneum in Italy. And there wasn't much to be done, but Richard's influence didn't stop. What he did is that he said, well, look, I'm at the University of Michigan, and there's this collection that has this binding that might be a candidate for a first attempt at virtual unwrapping. And in fact, this object, which was a copy of part of Ecclesiastes written in Hebrew, it actually became the first object that we ever virtually unwrapped, and it was the topic of my first PhD student's work on virtual unwrapping. So we collected data through the kind collaboration with Richard and his colleagues at the library on this piece, and you can see the layers in the tomography. These are the tomographic slices, and this was the data set on the right. And we turned that data set into the slices that are playing, we turned it into a voxel set that allowed us to see that there was going to be ink available on the reverse side. Now, the ink was easier for us to deal with at the time because there was an absorption coefficient that segmented it nicely from the substrate, which was parchment. And it also was a much easier segmentation problem because we're talking about very thick parchment as opposed to very thin, fibrous, damaged papyrus. In any case, the visible layer confirmed that in the X-ray we were absolutely seeing the ink, and then the conservator actually took it apart, and we were able to confirm that on the reverse side, what was clearly visible after the restoration, the physical restoration, was also visible in the virtual unwrapping. So this success, this early success, thanks to Richard, gave us inspiration and confidence beyond just a piece of canvas, right, that I put in a tomography machine. Because this was a real example that showed that we could have seen, without taking apart, right, we could have seen the text on the reverse side. So it led directly to the success that we ultimately had with the scroll from En-Gedi, which also was a scroll that was made of parchment, animal skin. and also was an ink that had some kind of heavy content in it, some kind of metal. We never really were able to do the materials composition experiment. I'll talk about this a little bit later. But we knew that the ink, because of the absorption, had to have had some kind of metal. And I mean, what a wonderful opportunity for me that I was able to use virtual unwrapping on this scroll from the Dead Sea Scroll collection. It came to me largely because we had been doing this work and we had been struggling. We didn't give up. And although I did not do the scan, so this picture of the scroll itself being scanned, it was done in Israel. The data was given to me so that we could take a crack at it. And of course, in hindsight, Penina Shore, the director of the Dead Sea Scroll collection, is quoted as saying it was a shot in the dark, a shot in the dark. But what I heard her say is, you get to take a shot. That's what I heard. And we took our shot and we were able to produce this completely unwrapped copy of the first 2 chapters of Leviticus written in Hebrew. And to complete this success story, our goal always was to promote scholarship, not in our technical community, but with the people who wanted to understand this in its context, biblical scholars. And so we were gratified to be able to publish a paper at the same time that we did the technical reveal, a paper with the scholars who were able to do a first edition, understanding this scroll in its biblical context. And so I want to make sure you understand how important I feel it is that virtual unwrapping be a step toward complete scholarly analysis of this material, which means that it involves the scholarly community that's in this room. So we developed virtual unwrapping as an engine for discovery where we believed that we could acquire data that would then promote, ultimately, scholarship. You can think of this whole thing as just a sort of big new kind of camera where we just take a picture of things and then give you that picture. And the details of how we do that are incredibly complicated and rely on all of these software steps that you've heard about today. But in the end, you get that image and then you can do scholarship. And that's been my dream. And so while I'm thanking Richard, I also want to thank Seth, who has been my lead engineer for a decade on building this piece of software that allowed us to basically realize all those steps and create the Getty success, and ultimately has led to our success at Herculaneum. So what I want to do with the time I have remaining is to talk about some projects that have led to an ecosystem that I think is important for the future, and then I'll talk about the vision for that future that includes some really exciting shovel-ready projects. So we did a series of projects along the way to build up our expertise and to work with what was available. We imaged the Venetus A in collaboration with the Center for Hellenic Studies and Harvard University. We imaged early on Herculaneum material at Paris, even though it didn't lead us in 2009 directly to solving this problem. It was a step along the way. We worked at Oxford University with the open fragments that they had. We scanned at the Morgan Library in Manhattan on a closed codex, Acts of the Apostles, M910. And even made some scans at the UCLA School of Dentistry while some of the scrolls from Italy were on display. We worked through partnership to be able to get access to equipment at the UCLA School of Dentistry and also to the objects themselves to be able to do that work. And the reason that we did that, because for all of these projects, we didn't have our own infrastructure, no equipment of our own. So everywhere we did this work, we were either setting up a laboratory sort of on site, a temporary laboratory, or we were partnering with someone who allowed us to use equipment to be able to do our work. And sometimes that worked, sometimes we failed, and sometimes there were misunderstandings, like this beautiful headline that came from the work we did at UCLA that basically said we sent the scrolls to the dentist for virtual unwrapping. So there were many people involved in partnership with me who were very unhappy with this headline. Well, let me just say that everyone was unhappy with this headline. So these kinds of misunderstandings and challenges, trying to build a lab on the fly for every project had led to my desire to build some kind of ecosystem at the University of Kentucky where we could, in a stable way, build infrastructure and could use that infrastructure when possible to have material come to Kentucky and we could do analysis there. So that was the birth of EDUCE Lab, and EDUCE Lab is based on the confluence of science and infrastructure applied to problems in heritage science. Heritage science is the interdisciplinary study of cultural or natural heritage, and I kind of look at it this way. You have science and technology, you have cultural inheritance, and then you have humans themselves, and you have this biological inheritance. And the confluence of all three of those things gives us this huge opportunity to make advances. If you throw cultural and biological inheritance underneath heritage science, you see all of these areas that begin to be included in the kind of science that you can do to be able to make research advance. The motivation actually is very nicely articulated from this UK Science and Tech Committee from 2005. We are at a turning point. Science and technology present a host of exciting opportunities to the heritage sector, and they must not be wasted. Kind of interesting, though, because as that was happening in the aughts and later in UK and in Europe, the USA was sort of showing a decidedly lacking kind of interest in developing heritage science. And you could sort of see not much growth there. So one of our research motivations was to try to explain to the funding agents in the United States that they might be able to concentrate some funding on an area of growth and of interest that is hugely exciting and important, for which we are going to make big strides. And we found a solution initially in a program at the National Science Foundation called the Mid-Scale Research Infrastructure Program. It was a long shot, but we found that it might be a fit to find funding in this program where it was attempting to bridge the gap from the National Science Foundation between the kind of infrastructure that you would try to acquire as a principal investigator in your lab. That'd be fairly small scale, less than $6 million worth of equipment and funding. And then the large scale equipment that we were using at national labs, like synchrotrons or telescopes, which would be 70 million and up. So we weren't really interested in building something in McMurdo, in Antarctica, right? But we were interested in this mid-scale area where we could acquire tomography, other kinds of instruments that would allow us to basically put a constellation of worthy equipment together and then go after this funding. And so that's exactly what we did. And we argued, following the path of the Europeans, that constellations of equipment are actually worthy as mid-scale, and that if you cluster them in a way that's acceptable to show their use cases, mid-scale might be actually a perfect example. So I put the EDUCE Lab team together at the University of Kentucky with these 5 investigators, and I also encompassed my own lab at the University of Kentucky in doing the scroll research and other work that I'd done with amazing staff and senior personnel. And we built basically this design for the infrastructure, and we went after this grant at the NSF. We built 4 operational units depicted here as Flex, Bench, Mobile, and Cyber. And these operational units are examples of infrastructure that are collected around a theme that allow us to do heritage science and in various areas. So you see on the right-hand chart, Bench is sort of lab-based work, mainly focused on material composition. So you see scanning electron microscopes, X-ray fluorescence, 3D microscopy, optical microscopy, tomography in that area. You also see Flex, Mobile, and then Cyber at the center. So everything inspired by AI. So these operational clusters are now being stood up at the University of Kentucky in Deuce Lab, and it's giving us the capability to do some amazing work in terms of material science as well as advanced imaging. They're bringing out the choir for my talk, I guess. Yeah. This is just some of the, these are some of the pieces of equipment in the bench cluster that will be available in our infrastructure suite for work when we bring objects to the lab and also work when you want to come to the lab and use this equipment. I want to point out specifically Flex because Seth mentioned it. We've built this very flexible X-ray environment that allows us to set up any kind of X-ray system that we want and then build imaging systems and software around that. X-ray is near and dear to my heart because it's been the key that has unlocked, the work we've done with Herculaneum. But there are so many more things that you can do. It basically is inspired by what we did at the National Lab and the synchrotron. So, Julian, this will be familiar to you because this picture was from the Hutch, right, in Diamond, where you guys were just last summer, right? And that hutch kind of inspired me. This is what the hutch looks like. It's at the end of the beamline, and it's an enclosed room where you can totally configure your experiment. Well, we built this vault at the University of Kentucky in our space. This is my whole team lined up in front before we actually deployed the space, which we moved into over the summer. This vault allows us 250 square feet inside a lead-lined space to be able to do flexible X-ray. So the equipment that Seth was talking about, maybe designing a field deployable X-ray machine that could solve the Herculaneum problem, perhaps we could design it in a space like this. We also have a mobile unit, a couple of vans with trailers that are stuffed full of great equipment that allow us to field deploy. So we can go to sites and do work that is not possible to take home. Archaeological sites, cemeteries, chemical sites that need testing. We can fly drones. So those two vans and the trailers that are associated with it allow us to field deploy. And then finally, everything is connected to a cyber infrastructure system that allows us to do in-house, pretty heavy-duty AI stuff. We have a cluster of 20 H100s with a high-speed backplane and a few petabytes of storage right now, set up and ready to go in terms of computational cycles, similar to what the other speakers were describing in terms of the experiments that need to be run with AI. So let me talk a little bit about the vision of this ecosystem and how we want to broadly engage the community. The system that we're building is supposed to be a user facility, so it's meant as infrastructure that will be open to the region. I don't think Michigan is that far away from Kentucky. I mean, I drove up here yesterday, so we could come up with the vans and do things, or you could come down and use our equipment. But the general idea is to realize these broader impacts because of how rich heritage science is, for one thing, and how the infrastructure will be able to be shared as a user facility, not just for my lab, but as a way for other users who are never going to be able to assemble, that constellation of infrastructure to be able to come and very quickly do good experiments and collect great data on their work. So let me talk about some of the emerging projects that I'm excited about that give you kind of a vision for how this infrastructure and how the trajectory of virtual unwrapping can kind of unlock some shovel-ready projects. First of all, we have all kinds of things in our region that are interesting. Jewett was a portrait painter, and he did some portraits of, for example, Thomas Jefferson. He also was copied frequently by people who weren't Jewett, but knew that he was famous. And so there are questions. There are contested paintings that are in Kentucky that people don't know if what their origin was or provenance. So here's a painting from our own collection at the University of Kentucky, and using the Bruker jet stream machine that you see on the right, we can do scanning XRF, which X-ray fluorescence allows you to infer a chemical composition at every point in a scanned region. So basically we can scan the entire painting and we can make an image of the painting, which is not an image of visible light, but it's an image of the chemistry of what's in the pigment at every point. And so here you see a really interesting result. I think, yeah, you should be able to see some incredible detail on the jacket that this person is wearing. And none of this is actually visible in the original painting. The original painting is like this big black blob, almost that like it was painted over at some point. And so then one starts to wonder, you know, was the painting revised? Did they cover up the detail because it would have given away the fact that it's not original? Like what happened here? So here's an interesting puzzle that our lab can help work on, can help solve, can help further. Here's another example from our region, I would say. You might think Louisiana is a little bit too far away, but Hurricane Katrina created problems for this church's archives because the archives got wet and then it created mold. And some of these documents that the church had cared for were very important in terms of the makeup of the congregation in an era when there were really no other records. And so you have these documents now that are damaged and they're difficult to care for. So it's possible with the EDUCE lab to go and do interventions or on-site digitization or careful research by sending these things. In fact, these examples came to our lab, and we started working on a way to maybe unwind some of the damage that has happened when the ink ran and the mold started to grow on these examples. And clearly, the Graves County Courthouse is a stark example of the fact that, you know, climate events continue, and that this courthouse, which is full of all kinds of documents, right, create a possibility for us to use advanced technology to either rescue things or on the front end, you know, to image things before the disasters happen. Here's another example. This was the manuscript we actually scanned at the Morgan Library in Manhattan, and it's an early copy in Coptic Greek of the Acts of the Apostles. It's one of the earliest copies, maybe one of the 5 earliest copies. Pages can't be turned because it's damaged, and it's beautifully rendered in this really thick script on parchment in iron gall. So it's a perfect candidate for virtual unwrapping. And we did some of that work, although we did this work on site at the Morgan Library. So it's Lower Manhattan, and you know, you're trying to fight with the union guys who will not unload the truck because they weren't paid to use the pallet jack. And so they go on a smoke break while Brent Seales uses the pallet jack. You know, it's that kind of thing, right? Way better to maybe bring the manuscript to the University of Kentucky, for example, right? So that we can do this work of virtually unwrapping the pages. And here's an example of one virtually unwrapped page. And then learning basically how to map that to photography, where you can sort of do this transfer function to make the X-ray that comes from virtual unwrapping actually look like a photograph to create an edition of this thing that's actually never going to be opened, right? So here's an example of kind of a project, a follow-up project that we would love to do at our lab, where we work with the Morgan Library, we bring this manuscript in, we image it in every way possible in our lab without having to operate a pallet jack in New York City. Another example, inscribed texts from the collection of the Israel Antiquities Authority. This replica shows an early experiment to try to image metal scrolls that have been inscribed. And it turns out that there are a number of these scrolls that have been excavated through various time periods in Israel, and they can't be opened easily because this is the condition that they're in. So a little bit different, because the challenge here is not making the ink show up. It's detecting this morphological feature of incised text. So here's an example of what's inside one of those. And this is basically an application of our virtual unwrapping software to a metal scroll. And the trick here is, how do you image the metal scroll so that you don't have all the beam hardening effects of what you normally would have when you've got really dense material. So nice collaborative project, very interesting. Let me talk for a minute about Petra. That's not a real building. You can't go inside there. I didn't know that. I'm just kidding. It's an amazing archaeological place, but what's interesting from my point of view is that there are manuscripts that have been discovered at a Byzantine church in the town of Petra, and those manuscripts, you can read about them in a 5-volume set that are available from ACOR, or you can also look at the Wikipedia page. But those manuscripts, which were physically opened, left behind a set of a dozen or two scrolls that couldn't be opened. So let me tell you what happened next after I got in touch with the director of ACOR, is that he agreed to allow some of the fragments from Petra to come to the University of Kentucky. And in our lab, we received authentic material from Petra with writing, which allowed us to do experiments in the lab. Okay, so that's what EduceLab and the power of EduceLab allows. We negotiated that agreement, and we did these experiments, and guess what we found? We found that the lead of Petra papyri, the ink of Petra papyri contains lead, and that lead gives us the ability to do virtual unwrapping fairly directly. So super exciting. One last shovel-ready project that I think will appeal to us, bringing it back to Herculaneum, and then I'll finish. It turns out that there were Herculaneum Papyri that were discovered not at the villa. This was actually discovered in one of the homes, and the home was called the Bicentennial Home because it was excavated on the 200th anniversary of the discovery of Herculaneum. This scroll looks awful, and yet the pieces that have fallen off show clear Latin text, and it's just completely unknown as to what might be in this scroll. Is it a documentary papyrus? Is it a literary papyrus? It is in Latin. No one knows. So the kind of ideal world that I believe EduceLab and the work we're doing together, the kind of ideal world I would like to see is a world where when these projects pop up, the community that we are building can work on them immediately. And through heritage science, we can basically build a very broad effort, not something that's based on a single person or a single piece of work, but a network, right? Where minds come together, scientists, conservators, conservation scientists, the people who are in this room, and computer scientists too. Thank you very much.
Because we have the last half hour today set aside for questions and future directions, I'm going to allow one question now. Very being shy.
Please make it be an easy one.
Okay, well, in that case, we'll leave all the questions to the end. Let's give another round of applause for
Thank you.